Okay, question 14 is asking us about a microwave oven that supplies 0.5 kilojoules per second. And it wants to know how many minutes should be set on the microwave in order to heat 250 grams of water. And it gives us a from and a to temperature. So I've written down some information that you would either have to memorize or would be given on the test, and I think you have to memorize this. So the boiling point of water is 100 degrees Celsius. And how do we even go about this problem? Well, the first thing we have to do is figure out how much energy it takes to heat that much water to boiling. So we need to know like how much energy in joules it takes to heat 250 grams of water from 24.3 degrees Celsius to 100 degrees Celsius. So remember the previous problem, we talked about this from and to. So from is our initial, to is our final. So we have some information already, and we have a weight of water, and we have to know, we have to have memorized the specific heat of water. So we have some variables that we're looking for here. So we have, we're looking for J, and we know that Q will find J for us. So we don't know what Q is yet. But we know our equation, we have it right here. So if we just pull out the information and we find the mass and the specific heat and the change in temperature, and we fill it in down here, then we just plug those numbers into our equation to find Q. So let's do that. So it says our mass is 250 grams of water. And we have to have memorized that water is 4.18 joules per grams degrees Celsius. That's its specific heat. Then we have our from temperature, which is our initial temperature, because we're going from this temperature to this temperature. So our from, or our initial, is 24.3 degrees Celsius. And our final is 100 degrees Celsius, right? Because our final temperature, we want it boiling. Okay, now we have all our numbers. We can figure out how much energy it's going to take to heat up 250 grams of water. That's the first part of our problem. So let's just plug in those numbers. We have a mass of 250 grams times 4.18 joules degrees Celsius. And I'm going to do the same way I did it before. So I'm going to do final minus initial. And I'm going to do this separately on the calculator, because that's just how my brain works. All right, so we're going to go to that calculator, which always likes to be nice and big for me. And we are going to plug in our information. So we had 250 grams of water times its specific heat, and that gives us this answer. But we need our change in temperature, which was 100 minus 24.3. Okay, it pulled up everything from before, but we're just looking at the last two numbers, and we want to multiply those last two numbers. We get a big number. Joules, you're going to get big numbers all the time, so that's okay. 79106, so our Q equals 0.5 joules of energy needed to heat that much water to boiling. Okay, so we found Q. We're not done yet though, because that isn't what the question is asking. The question is asking, given this feature on the microwave, 0.5 kilojoules per second. How many minutes would it take to heat up this? How much time, if we know it's 0.5, let's write that down. We need minutes, so we're looking for minutes. Okay. And let's write down what we're given. We're given 0.5 kilojoules per second. And we found how many joules it takes. So we need to either convert this to kilojoules or this to joules. And I'm going to convert this to joules, but you can do either one. So we know there are 1,000 joules in a 1 kilojoule, and that takes care of my kilojoules, all right? But we want minutes, so we have joules on top, seconds on bottom. How can we get rid of joules? Well, we're going to put in the number we found, because that's the only number we have that has joules in it, so we can cross that off now. And that's not a conversion factor, that's just something that we know that we had to find. So now we want to get rid of seconds. So we have joules crossed off, kilojoules crossed off. We have seconds on bottom. We want minutes on top. So we want minutes on top. And you know what? I have this flipped around. Let's hurry and erase this. Oh, so I want minutes on top. So I'm going to write seconds on top. And if you do that, if you come across this problem and you're like, oh no, I need to flip things around, That's okay. All right. So and then we have our 1,000, oops. We have 1 kilojoule per 1,000 joules. Okay, cross those off. And we have our 79,106.5 joules per 1. We can cross off joules. Okay, now we have seconds on top. We need minutes on top, so we can put seconds on bottom, minutes on top. So how many seconds in a minute? We're going to hop over to our calculator. Clear all this. And we will do 79,106.5 times 1 times 1 times 1. So we don't need any of that. Let's go back over here. And then we're going to do divided by, we have a whole laundry list of things we're dividing by. 1,000 times 0.5 times 60. And we get 2.6368. So 2.6368 what? Minutes? All right. We want to check our significant figures. So in the problem we have, this is a known conversion. So we don't look at that one. That's not considered. We have 3 sig figs in the rest of the problem. So we want to go to 3. So let's underline the 3 we want. Look at one more. That gives us 2.64 minutes. And he has 2.63, which means that we just rounded a little bit differently. Rounding errors come into play. So if your answer that you find on the test is off by 0.1, you're probably correct. And I hope that helped.